हेलो स्टूडेंट्स। आई होप आप सभी अच्छे होंगे और अपनी पढ़ाई को भी अच्छे से कर रहे होंगे। तो आज का जो हमारा टॉपिक होने वाला है वो हाइपरबोला होने वाला है। हाइपरबोला, तो सबसे पहले हम इसकी थ्योरी डिस्कस करेंगे। ओके, और थ्योरी में हम मेनली रिजल्ट्स देखेंगे, हम प्रूफ नहीं करेंगे। ओके, और वो जो रिजल्ट्स होंगे वो फ्रॉम द कॉम्पिटिटिव पर्सपेक्टिव काफ़ी इंपॉर्टेंट रिजल्ट्स रहेंगे, जो कि आप डायरेक्टली किसी भी क्वेश्चन को इस टॉपिक से रिलेटेड सॉल्व करने के लिए यूज कर सकते हैं। ओके, तो बढ़ते हैं आगे। आज की थ्योरी में हम क्या क्या पढ़ने वाले हैं देखते हैं। हाइपरबोला, उसकी डेफिनेशन जानेंगे। हाइपरबोला से रिलेटेड टर्म्स जानेंगे। इक्वेशंस ऑफ हाइपरबोला इन स्टैंडर्ड फॉर्म। टेंजेंट टू अ हाइपरबोला। रिजल्ट्स ऑन टेंजेंट। नॉर्मल टू अ हाइपरबोला। रिजल्ट्स ऑन नॉर्मल्स। पोल एंड पोलर। Conjugate points and conjugate lines. Director circle. Asymptotes. Results on asymptotes. Rectangular or equilateral hyperbola. Rectangular hyperbola of the form x square minus y square is equals to some constant square. And the last topic subtopic will be rectangular hyperbola of the form xy is equals to c square. Okay, let's now dive deep into our subtopics one by one. So, before going to our subtopics, let me just give you a small disclaimer. The images used in our slide deck are just for educational purposes only. We respect the intellectual property rights of the original creator and owners of these images. If you are the owner of any of the images used in this deck and have any concerns or issues, please contact us at sathi@iitk.ac.in and we shall remove the images. Thank you. Now, definition for hyperbola. So, concept of hyperbola. A hyperbola is a set of all points xy in a plane such that the absolute difference of the distances from two fixed points, namely foci, is constant. So one definition is this. Another is hyperbola is the locus of a point in a plane which moves in a such way that the ratio of its distance from a fixed point called as a focus in the same plane to its distance from a fixed line called as directrix is always constant and greater than 1. Okay, mathematically sp divided by pn must be some constant and this e must be greater than 1. Now terms related to hyperbola. Let me just go through some important terms related to hyperbola. Like vertices, the points a prime and a, where the curve meets the line joining the foci s and s prime, foci s prime and s, okay, are called the vertices of hyperbola. Now transverse and conjugate axis. Transverse axis is one of which lie along the line passing through the foci and perpendicular to the directrix. तो आप देख सकते हैं यहाँ पर आपकी फोकी जो ये एक्स एक्स प्राइम जो लाइन है फोकी से पास हो रही है और डायरेक्ट्रिक्स के परपेंडिकुलर है, तो वो आपकी ट्रांसवर्स एक्सिस होती है। एंड कॉन्जुगेट एक्सिस इज the one which is perpendicular to the transverse axis and passes through the midpoint of the foci, that is center. So आपका जो foci है S prime S, उसका जो मिड पॉइंट है वो है सेंटर C. तो ट्रांसवर्स के परपेंडिकुलर और सी पॉइंट से पास होती हुई जो आपकी लाइन होगी वो आपकी होगी कॉन्जुगेट एक्सिस. नाउ द सेंटर द मिड पॉइंट सी ऑफ ए prime, so midpoint a prime, okay, bisects every chord of the hyperbola passing through it and is called the center of hyperbola. Okay, now some more terms related to hyperbola. Focal chord, chord of a hyperbola which is passing through the focus is called focal chord of the hyperbola, as you can see. So q prime is our what? It is a chord. If it passes through focus, then it will be called as focal chord. Now directrix, a line which is perpendicular to the axis and is lies between center and vertex. As you can see, here's your vertex, here's your center. So line in between lies between the center and the vertex, and whose equation is x is equals to plus minus a by e. Now double ordinates. If q be a point on hyperbola, draw qn perpendicular to the axis of the hyperbola. Qn perpendicular to the transverse axis and produce to meet the curve again at q prime. Then q prime is called double ordinate of q. So double ordinate of q. Now latus rectum, the double ordinate passing through focus is called latus rectum. If double ordinate passing through the focus, as you can see, so this is your what? Latus rectum. Okay. Now some more terms related to hyperbola. There is a note. The vertex divides the join of focus and the point of intersection of directrix with axis internally as well as externally in the ratio E:1. Now domain and range of hyperbola of this form. Domain is this: x less than equal to minus a and greater than equal to a, and where y belongs to the real number. The line through the foci of the hyperbola is called transverse axis. The line through the center and perpendicular to the transverse axis of hyperbola is called conjugate axis. Equation of hyperbola in standard form. If the center of hyperbola is at origin and foci are on the x or either y axis, then the types of equations are called the standard equation of an hyperbola. Hyperbola of the form x square by a square minus y square by b square is equals to 1. When the hyperbola is in the given form above, then it is called the standard equation of an hyperbola. From here you can say that center is at origin 0 comma 0, foci at s and s1, s and s1, coordinates ae comma 0 minus ae comma 0 respectively, vertices a1, a a1, a comma 0 and minus a comma 0. Directrices equation will be L is equals to L is equals to a by e and L prime is equals to minus a by e. Now the length of latus rectum L prime and L dash L1 dash. So L dash L1 dash, this latus rectum L1, this latus rectum length will be twice of b square by a. Now eccentricity A and AB relationship will be E is equals to root of 1 plus B square by A, okay, the whole square, or B square is equals to A square E square minus 1. Okay, so the square will be on both B by A. Length of transverse axis 2A, length of conjugate axis 2B, equation of transverse axis y is equals to 0, equation of conjugate axis x is equals to 0, focal distances of a point on the hyperbola is ex plus minus a, and differences of focal distance of a point on the hyperbola is fixed, which is 2a. Now equation of hyperbola in standard form. Conjugate hyperbola equation is minus x square by a square plus y square by b square is equals to 1. The hyperbola whose transverse and conjugate axes are respectively the conjugate and transverse axis of the given hyperbola is called the conjugate hyperbola of the given hyperbola. The conjugate hyperbola of the hyperbola x square by a square minus y square by b square is equals to 1 is minus x square by a square plus y square by b square is equals to 1. Now, center will be at origin 0, comma 0. Foci S and S1 will be at 0, comma BE and 0, comma minus BE respectively. Vertices at A 0, comma B and A1 0, comma minus B. Directrices Y is equals to B by E and Y is equals to minus B by E. Latest rectum length L1 L prime L1 prime will be twice of A square by B, and eccentricity relationship will be E is equals to root of 1 plus A by B whole square, or in other words A square is equals to B square product with E square minus 1. Length of transverse axis 2B, length of conjugate axis 2A, equation of transverse axis x is equals to 0, equation of conjugate axis y is equals to 0. Now equations of hyperbola in standard form. Focal distances of a point on hyperbola is EY plus minus B. Differences of focal distances of a point on the hyperbola is twice of B. There is a note. If the center of the hyperbola is h, comma k and x's are parallel to the coordinate axis, then the equation will become x minus h whole square divided by a square minus y minus k whole square divided by b square is equals to 1. Now results on hyperbola x square by a square minus y square by b square is equals to 1. Foci of a hyperbola and its conjugate are cone cyclic, meaning that foci, okay, and foci of hyperbola and its conjugate will lie on a common circle, okay, and forms a vertices of a square. Clear? The points of intersection of the directrix with the transverse axis are known as foot of the directrix. Latest rectum L twice E, distance between the foci and the foot of the corresponding directrix. Parametric equation of a hyperbola is x is equals to a sec theta and y is equals to b tan theta, where theta belongs to 0 to 2 pi open interval. The position of a point hk with respect to the hyperbola, meaning that either the point lie inside or on or outside the hyperbola, How we are going to determine that? Very simple. That put uh, this take this as your expression x1 whole square divided by a square minus y1 whole square divided by b square equals to, sorry, minus 1. This will be your expression where x1 and y1 will be what your point that you have to determine it is lying outside, inside, or on the hyperbola. Now, if s1 is greater than 0, then it will be inside the hyperbola. If s1 is equals to 0, then it will be on the hyperbola. If less than 0, then it will be outside the hyperbola. Okay. Now, tangent to a hyperbola, let's see, a line which intersect the hyperbola at only one point is called the tangent to the hyperbola. As you can see, this point. So, line passing through the point P and touching the hyperbola will be our tangent at point P. In point form, the equation of the tangent will be what? X1 divided by a square minus y1 divided by b square is equals to 1. In slope form, the tangent equation will be y is equals to mx plus minus root of a square m square minus b square. In parametric form, x by a sec theta minus y by b tan theta is equals to 1. At what point? A sec theta, b tan theta. The line y is equals to mx plus c touches the hyperbola if and only if these conditions follow, that c square is equals to a square m square minus b square, and the point of contact will be plus minus a square m by c comma plus minus b square by c, where c will be root of a square m square minus b square. Now some more results on tangent. Two tangents can be drawn from a point to a hyperbola. The point of intersection of tangent T1 and T2 to the curve xy is equals to c square is 2c T1 T2 divided by T1 plus T2, comma 2c T1 plus T2. The tangent at the point P, a sec theta 1 b tan theta 1 and Q, a sec theta 2 b tan theta 2 intersect at the point R, where uh, a cos theta 1 minus theta 2 divided by 2 divided by cos theta 1 plus theta 2 divided by 2, and y ordinate will be b sine theta 1 plus theta 2 divided by 2 cos theta 1 plus theta 2 divided by 2. The equation of pair of tangents drawn from an external point P x1 y1 to the hyperbola is s1 is equals to t square, where s is x square by a square minus b square by y square by b square minus 1. S1 will be x1 square by a square minus y1 square by b square minus 1, and t will be tangent equation, tangent expression, as you can see. So x1 divided by a square minus y1 divided by b square minus 1. The equation of chord of contact is x1 by a square minus y1 by b square is equals to 1, or in other words t is equals to 0. The equation of chord of the hyperbola whose midpoint is x1 y1 is t is equals to s1. So what is your t? T is just nothing but this x1 by a square minus y1 by b square minus 1. So t is this and s1 is this. So you can cancel minus 1 from both sides. You will have this equality. Equation of chord joining the points a sec alpha b tan alpha and a sec beta b tan beta is x by a cos alpha minus beta by 2 minus y by b sine alpha plus beta by 2 is equals to cos of alpha plus beta by 2. Now normal to a hyperbola, so this is just nothing but a line passing through the point P and perpendicular to the tangent. A line which is perpendicular to the tangent of a hyperbola and normal to the hyperbola. Simple. In point x1 y1 form, so normal equation will be a square x by x1 plus b square y by y1 is equals to a square plus b square. In slope form, y is equals to mx minus plus m a square by a square plus b square divided by root of a square minus b square m square, and the point of intersection will be plus minus a square by root of a square minus b square m square, and y ordinate will be minus plus v square m divided by root of a square minus b square m square. In parametric form, ax cos theta plus by cot theta is equals to a square b square at a sec theta plus b tan theta. Now results on normal. If the straight line Lx plus My plus n is equals to 0 is a normal to the hyperbola, x square by a square minus y square by b square is equals to 1, then a square by l square minus b square by m square is equals to a square plus b square whole square divided by n square. Four normals can be drawn from any point to a hyperbola. The line y is equals to mx plus c will be normal to the hyperbola x square by a square minus y square by b square is equals to 1 if this conditions follow: c square is equals to m square a square plus b square whole square divided by a square minus b square m square. If the normals at 4 points p x1 y1 q x2 y2 r x3 y3 and s x4 y4 on the hyperbola x square by a square minus y square by b square is equals to 1 are concurrent, then x1 plus x2 plus x3 plus x4 product with 1 by x1 plus 1 by x2 plus 1 by x3 plus 1 by x4 is equals to 4. Okay. Now pole and polar definition. Let P be a point inside or outside a hyperbola, then the locus of the point of intersection of two tangents to the hyperbola at the point where secants drawn through P intersect the hyperbola is called the polar of point P with respect to the hyperbola, and the point P is called the pole of the polar. Polars of 2 points P Q of hyperbola x square by a square minus y square by b square is equals to 1 are x1 by a square minus y1 by b square is equals to 1, and x2 by a square minus y2 by b square is equals to 1. If the polar of point P passes through point Q x2 y2, then x1 x2 divided by a square minus y1 y2 divided by b square is equals to 1, and the polar of Q x2 y2 passes through P, then x1 x2 divided by a square minus y1 y2 divided by b square is equals to 1. Conjugate points and conjugate lines. 2 points said to be conjugate points with respect to a hyperbola if each lies on the polar of other. Two lines are said to be conjugate lines with respect to a hyperbola x square by a square minus y square by b square is equals to 1 if each passes through the pole of the other. Two lines L1x plus M1y plus N1 is equals to 0, L2x plus M2y plus N2 is equals to 0 are conjugate lines with respect to a hyperbola x square by a square minus y square by b square is equals to 1 if this condition follows: a square L1 L2 minus b square M1 M2 is equals to N1 N2. Now the director circle definition. Locus of the point of intersection of tangents to the hyperbola x square a square minus y square by b square is equals to 1, which are perpendicular to each other, is called director circle. The equation of director circle is x square plus y square is equals to a square minus b square. The circle x square plus y square is equals to a square is known as auxiliary circle of both hyperbolas. Okay, so as you can see, so one tangent is this, another one is this, both making at point P a 90-degree angle. Okay, so collection of all such points will be your director circle. Now asymptotes. An asymptote to a curve is a straight line which touches on it 2 points at infinity but which itself does not lie entirely at infinity. Now results on asymptotes. A hyperbola and its conjugate hyperbola have the same asymptotes. The angle between the asymptotes of hyperbola x square by a square minus y square by b square is equals to 1 is 2 times tan inverse b by a. Asymptotes always passes through the center of the hyperbola. The bisectors of the angle between the asymptotes are coordinate axes. The asymptotes of a hyperbola are the diagonals of the rectangle formed by the lines drawn through the extremities of each axis parallel to the other axis. Rectangular or equilateral hyperbola. A hyperbola whose asymptotes include a right angle is said to be a rectangular hyperbola, or if the lengths of transverse and conjugate axes of any hyperbola is equal, then it is said to be a rectangular hyperbola. Now, rectangular hyperbola of the form x square minus y square is equals to a square. Asymptotes are perpendicular lines, that is x plus minus y is equals to 0. Eccentricity will be root 2, center at 0 comma 0. Foci at s1 will be plus root 2a comma 0 and minus root 2a comma 0. Directrices will be plus minus a by root 2. Latest rectum length twice of a. Point form x is equals to x1, y is equals to y1. Equation of tangent x1 minus y1 is equals to a square. Equation of normal x1 by x plus y1 by y is equals to 0. Parametric form x is equals to a sec theta, y is equals to a tan theta. Equation of tangent x sec theta minus y tan theta is equals to a. Equation of normal x by sec theta plus y by tan theta is equals to twice of a. Now, a rectangular hyperbola of the form xy is equals to constant square. Asymptotes are perpendicular lines, that is x is equals to 0, y is equals to 0. Eccentricity E is equals to root 2. Center at 0 comma 0. Foci S at root 2c comma root 2c and S1 at minus root 2c comma minus root 2c. Vertices V1 c comma c and V2 as minus c comma c. Directrices x plus y is equals to plus minus root 2 times c. Latest rectum will be twice of root 2c. Point form will be x is equals to x1, y is equals to y1. Equation of tangent will be x y1 plus y x1 is equals to twice of c square. In other words, x by x1 plus y by y1 is equals to 2. Equation of normal x x1 minus y y1 is equals to x1 square minus y1 square. Parametric form x is equals to ct, then y is equals to c by t. Equation of tangent x plus yt square is equals to 2ct. Equation of normal t square x minus y is equals to c times t cube minus 1 by t. So this will be the end of our theory session. Okay, so we will be doing one or two practice questions related to this theory. So for now, just wait for a moment. So now let's see one or two questions related to the theory. Okay, just try to be attentive. Now practice questions part 1. What we will be seeing, practice question 1 to 6. Okay, we are not going to complete all of the, as we do not have the required time for now. Now this small disclaimer for our viewers: the images used in our slide deck are just for educational purposes only. We respect the intellectual property rights of the original creators and owners of these images. If you are the owner of any of the images used in this deck and have any concerns or issues, please contact us at sathi@iitk.ac.in and we shall remove the images. Thank you. Now, the first question: if the vertices of hyperbola are 0, plus minus 6 and eccentricity is 5 by 3, then first, the equation of hyperbola is y square by 36 minus x square by 64 is equals to 1. The foci of hyperbola are 0 plus minus 10. So you have to answer that among these options, which one is correct. First option is saying both 1 and 2 are true. B is saying only 1 is true. C is saying only second is true. And D is saying that both are false statements. Okay. So you will have 30 seconds to try this question. Okay, then we will explore the detailed solution of this. Okay, in between you can answer. So your time starts now. So option B, uh, students option B को choose कर रहे हैं. Okay, so only one is true. Okay, majority students one को true बता रहे हैं, option B correct बता रहे हैं. Let's see. So as your time's up, so let's see the solution and its correct option. So let me once again uh, decode the question for you. If the vertices of hyperbola are, so vertice is given to you 0, plus minus 6. This means Your transverse axis, the axis of hyperbola will be on y-axis. Okay, and its eccentricity is 5 by 3, obviously greater than 1. Then the equation of hyperbola is y square by 36 minus x square by 64 is equals to 1, and the foci of hyperbola are 0 comma plus minus 10. So correct option will be A, that both the statements are true. Let me just go through how are they true. The first thing is formula and key points used in this solution. If the vertices of hyperbola are on y-axis with origin as the midpoint, the equation of hyperbola of the form y square by a square minus x square by b square is equals to 1. Now, solution. Since the vertices are on the y-axis, as we already said this, with the origin as the midpoint, okay, means the center, the equation is of the form y square by a square minus x square by is equals to 1. Now, using the centricity, we have to find out the a and b. So as vertices are 0 comma plus minus 6, a will be 6 and b square will be equals to a square product with e square minus 1, which is 36 times 25 by 9 minus 1. So solving this, you will have b square as 64. So you can replace your a square and b square. A square by 36 and b square by 64. You will have your equation of your hyperbola, which is already given to you in the first statement. Now, so this gives you the required equation of the hyperbola y square by 36 minus x square by 64 is equals to 1, and the foci from here you can easily say the foci will be 0 comma plus minus AE. A is 6, E is 5 by 3, this means 10. So 0 comma plus minus 10 will be your coordinates for foci. That's why both the statements are true. Okay, so let me just provide you another question. Now the second question, equation of the hyperbola with the length of latus rectum is 8, eccentricity is 3 by root 5. So you have to find out among these four equation which one will be the equation of the hyperbola which satisfy the given conditions. Okay, so you will have 30 seconds. Please try. So your time starts now. So let's proceed towards the solution. Let me just once again read the question for you. The equation of the hyperbola with the length of latus rectum is 8 and eccentricity with 3 by root 5 is. The correct option will be B. 4x square minus 5y square is equals to 100. So the formula and key points used in this solution for this solution is, one is equation of hyperbola x square by a square minus y square by b square is equals to 1. Latus rectum is 2b square by a. Eccentricity relationship e square is equals to b square by a square plus 1. Now the solution. So let the equation of conjugate hyperbola be y square by b square minus x square by a square is equals to 1. So this gives and we already have length of latus rectum is equals to 8. So this gives me 2b square by a is equals to 8, means b square is equals to 4a square times e minus 1 is equals to 4a, means a times e minus 1 is equals to 4, means we already given with e, so we can replace e, okay, and from here you can have a times 9 by 5 minus 1 is equals to 4. From here you can easily find a value as 5. So putting a, you will have b as what? B square will be 20. Hence, the equation will be what? X square by 25 minus y square by 20 is equals to 1. Okay. We already gave the some extra information related to conjugate hyperbola, so that was not necessary for this solution. Okay, that was something extra. So this is it from our side. I hope you enjoyed the theory and the question session. So now we are going to end this session. So thank you.